Hi, today we will be discussing about the physics 1 circular motion, because so far we have covered on the kinematics of the two dimension problem, the linear motion, that means the projectile motion where if you are throwing a ball, so the ball will travel all the way and then probably catch by somebody on the other end. So, the ball travels all the way x and y, and then at the maximum height you got only x, there is no y. Then by gravity it is supposed to fall down with the x and y. Eventually it is going to reach on the other side. So far we dealt with the linear motion, that means linear in terms of x motion and y motion, right. We did work on the x and y motion and also worked with the kinematics of two dimensions, all kind of kinematic equations we looked at it. Before getting the circular motion, I would like to give another concept which is also referred often is called relative motion. You know, the motion you can make in linear or circular, but that should be with respect to what? So, there is a relation or relative motion. For example, if I am standing here and then if someone is walking by, so what is the speed the guy who is walking on the hallway compared to me, I am stand still on this place. If you are standing on the road, someone is bike riding, so what is the velocity of that guy with respect to someone is standing without any motion? And someone is riding a car, then what is that guy's velocity who is driving a car with respect to a guy who is bike riding or who is standing. So, I am going to talk about the relative motion. The motion is relative, it is not absolute. So, for example, if I take a guy who is standing is called A, at the same time a guy who is just taking his bike and then is riding a bike, this he is riding a bike, let us say we put name B, he is riding a bike with a velocity of this guy is 5 meters a second, right. And then another person who is driving a car, so he is on his car, the car is, so this person is called C. So, the car is driving with a velocity is 15 meters a second. So, you have three people, the A is no motion. So, the no motion means that is 0 meters a second, B is riding a bike with a 5 meters a second, and C is riding a car or driving a car with a 15 meters a second. So, the motion is relative. What that means? The motion of B with respect to C, the motion of B respect to A. What is the motion of the velocity of B with respect to A? If you look at it, so the B is at 0, A is at 0 and B is at 5 meters a second, then you can come to a conclusion the B is on the positive x axis. If you will try to draw a coordinate, this is x, this is minus x, plus y and minus y. So, if you look at from z, the velocity of B with respect to A is on the positive coordinate. So, he is about 5 meters a second away from A, that is the velocity. What is the velocity of B with respect to the guy who is driving a car? 15 meters a second. So, you are looking back from him, then you will get your relative velocity. So, let us put an equation. I want to find the velocity of B. So, this velocity is called the x motion. the velocity of x motion of the B with respect to C. So, the guy who is riding a bike, what is his velocity with respect to the guy who is driving a car? How can you get it? You see there are two subscripts. The subscript is, this is called B and C, or the B is relative to C. Then the equation for relative motion is, if you want to look at it, then I want to look the B with respect to A and then C with respect to A also. So, if you look at it, I can write an equation, the velocity of the guy who is riding a bike B with respect to guy who is standing on the road, and you are taking a velocity of the guy who is between A and C. This is a relative motion equation. In this equation, you will notice that if you want to find B and C, then you have to make a relation. The B should be on the outer subscripts, and the same time the C is on the outer subscript. So, if you look at, for I want to find BC, I can put my B on the outer subscript, the same thing on the outer subscript of the C. Then I am bringing my inner subscript A, which is common to both B and C, then I will just add this one. So, the equation is, if you want to get anything on the BC, then I can keep that in outer and then bring the third guy in inner subscript. That way you can solve this equation, you can find any unknown quantity or the velocity. I will also give one other equation. If I want to find B A, then you can also write the equation. I have in x motion, the B you put outer, the same thing the A you put outer, you can bring your C in between, you can fulfill the equation. So, the equation for B A is B and A should be outer, so that you can bring the C should be inner, that way you can solve the problem. So, for this problem, if you look at it, I want to find the velocity of B with respect to C, right. So, what is the velocity of B with respect to A? So, he is riding with a 5 meters a second, 5 minus 0 is 5 meters a second, right. And what is the velocity of C with respect to A? So, C with respect to A, or this is A with respect to C. You can also write this equation. If I can write V x A with respect to C is nothing but minus V x C with respect to A. So, if I want to find the velocity of this guy A with respect to C, then I just take an inverse or negative sign. So, I can put V x C with respect to A, that means velocity of C with respect to A. So, I have those numbers, I can plug in the number like 5 meters a second minus 15 meters a second. I can find my velocity of a B with respect to C is minus 10 meters a second. This is just a comparison of 3 guys or with a 3 different speed. Then how can I get a speed of any one person with respect to other 2 persons who are with a different speed? So, that is one of the problem which is called a relative motion. The relative motion will give you the motion relatively with respect to different velocities at different time. So, on this, if you look at it, I have 3 reference of frames. The frame of references is 3. So, if I look at this, the reference frame is 1, that is a one reference frame, and then the second reference frame, then third reference frame. You may be wonder why I am, what is actually a reference frame? It is nothing. What I am standing here, I am talking, I am with this the volume of a room, that is called a reference frame. I am in a frame of reference, means I am in this cyber gaming and media lab, that is my reference. Okay. If somebody is walking on the hallway, that reference frame is respect to the hallway reference, right. So, the position of a guy who is standing on the hallway with that reference, okay, someone is standing in between the hallway and this cyber gaming media lab, then what is his coordinate of that guy who is in between the two references? Because sometimes the problem is you are standing and your train is passing by, what is the velocity of the guy who is inside the train is in a different velocity, different reference frame, then what is the velocity of that guy who is in a different frame compared to you are on the station. So, that is a interesting problem, you can look at it, because the position coordinate always depends upon position, velocity, acceleration, all depends upon the reference frames, right. So, I have a reference frame, let us say that I draw a reference frame, this reference frame is named as A. So, A has got x, y and z axis, and then I have another reference frame, that is B, that also has got x, y, z. The same thing for B is x, y and z. Now, so the A will be, could be moving reference frame or it could be standing reference frame. So, you treat that as two different frame of references. Now, I have a point or some object which is lying on in between A and B, that is called C. So, what is the position of this guy C with respect to frame 1, that is frame A, or with respect to frame B? Okay. So, how can you get that? So, if I draw, you know, from Cartesian coordinates, if you draw the line from my origin of A to C, what that call is the position vector RCA, that is the RCA position vector. And then if I draw, there is you can also find one reference frame A to B, that is called RBA vector. So, you connected with the C, you also connected with the B. From your vector addition, you know, the vector algebra or vector addition, you can complete the triangle. That triangle will give you the reference frame RBA or I am sorry RCB. So, you have three position coordinates, the one position coordinates with respect to A frame to C, the one with the two reference frames, and the one with the B frame to C frame. So, overall your equation, you can write a position coordinate of one reference frame I want to find out. It is a very similar. I say that you can take these two in outer subscripts and bring in the one with the inner subscript. So, if I want to find CB, what is CB? The position coordinate of a CB is nothing but RC outside plus RB outside. So, what is inside should go is RCA and RAB. So, you can find RCA, that is this vector you can get, So, I can directly get this vector RCA, and I can also get RAB or RBA, that is this vector. So, you get at these two positions, you get this vector that is very similar to what you do with the tip and tail method or parallelogram method. You can do the two reference frame we are talking about. We are not talking object is moving in one direction on one uniform plane. It is two different planes. We are combining, we are taking two reference frame and picking some particle or object and defining the coordinates and position. Once you know the position, you know your velocity. Velocity is what? Velocity is derivative of position. So, you put this derivative. So, you can take the dRCB is dRCA by dt plus dRAB by dt. So, that means my derivative of position is called your velocity. So, you can find the velocity CB is equal to V CA plus VAB. So, this is a equation called relative velocities. Relative velocities in two different frame of reference. Therefore, this equation is called Galilean transformation. Galileo is a very famous astronomer, astrophysicist. So, he did lot of astrophysics and stellar objects. So, this transformation is called Galilean transformation. With this Galilean transformation, what that means, the Galilean transformation is a relationship of velocities in two different frame of references. You have frame A and frame B, you find the velocity of an object between the two frames, then that is so called Galilean transformation, right. So, with this relative motion in mind, the concept, we will be working out the problems in the classroom. So, you can just go through this and understand the concept, so that we will take the problems in the classroom for work it out for in class exercise. That is about the relative motion. So, after the the relative motion, we will be looking at a concept called circular motion. Circular motion, because so far in this kinematics, one dimension, two dimension, you just saw applications whether the car is driving on the road on a x axis x motion, or you are throwing something, a ball on a projectile motion, that is a x and y, or something is falling down straight, that is a y motion. Oftentimes you may encounter a circular motion. For example, some of the example problem like if you go, if whenever you exit out of an airport, right, you go to Tampa International Airport or Orlando, you often encounter to get onto I-4, you have to take all the way the circular path, the circular motion. So, you will be on I-275, all of a sudden you want to get onto exit, then you will take a path of a circular motion. So, the circular motion, what it governs, because you know from your linear motion, if I say linear motion, you immediately tell what are the kinematic equations we deal with, right. We deal with summation of final velocity is initial velocity plus a x delta t, which was the kinematic equation for the velocity. We know the final position of any object x or y. I put this is x or y in terms of s, even this I change it to s, that way it is a generic x or y motion. So, S f final, which is S I final V I final delta t plus 1/2 A S delta t square. This you already did lot of problems based on this. then also we have Vf square is Vi square plus 2a is delta S. We have seen this all these kinematic equations, one dimension, then you use S, two dimension you use x and y. If x you use, if x motion you use Ax, if y motion you use Ay, which is your gravity minus g. Okay? Minus g is 9.8 meters per second square. So, that is all about, as long as you are on the highway just going north south or east west, you will be following this equations to get your velocity, acceleration, everything. How about on the circular motion? So, if you take cartwheel or any object which is riding on a circle, so you pick up any particle. So, the particle from the center of a circle, you know, the radius is always, the radius of the circle is r. So, you pick up any particle. So, if I pick one particle here, still the radius is r. If I pick one other particle, still the radius is r. The radius of the circle is r, and then you take a circle. So, this forms an arc. You see, this forms an arc. The arc is nothing but your S, and then if I make an angle, you can also get your angular, because whenever you talk about circle, then immediately you should know about the trigonometric relations. So, angle involved. So, the angle is theta for any circle. So, this could be from this position to this position or this position to this position. So, anywhere you want to take out, you get your angle involved. Let me tell you at the outset, we deal with the linear motion. What are the parameters we deal with? X 0 is initial position, or y 0, x, or let us put x I, y I, x final, y final, V x initial, V x final, V y initial, V y final, A x, A y, right, and then T I T F. All these parameters we use for linear. So, in angular or circular motion, so if I say angular or circular motion, the position, whatever the linear position is dealt with, could be replaced by theta I. Theta I is the initial angle it makes, and theta final is your final position. So, that is called angular position. Angular position. Then the velocity is replaced by, again in physics, one or two, the concept is almost same, like your physics never change in, even if we talk about the celestial bodies or stellar bodies, or if we talk about high energy physics or elementary physics, physics will be the same, only you look for some letters. Instead of linear velocity, I say this is angular velocity, omega I, omega final. So, that means angular velocity. Acceleration, I say the acceleration, alpha I, alpha final. So, I put a linear acceleration, here it is angular acceleration. This is a time, we use a period. Okay. If you look at this circular motion, I just segmented the circular motion in the x and y axis. So, I just took one of the segment, that is called my arc. So, this is called the arc length S. Okay. So, I just took a segment of a circular motion, and this is a radius. So, we came up with a equation that is called my angle is equal to my arc length over radius. Okay. S over r, or I can also write S is equal to R times theta. It is interesting to note that on your left hand side, that is a S is linear, okay. That is a linear position or linear displacement. On the right hand side, you will see this is angular. What is the connecting bridge between these two, linear and angular, is your radius. It is very simple. If you are on the road on the linear scale, suddenly you get onto curve, the circular motion, then you can relate the linear to circular by a bridge, that is called your radius. If you know the radius of the circle, the problem is solved. That is a connecting bridge between linear quantities and the angular quantities for any problem related to linear motion and circular motion. Okay. So, that is very important to connect it, because you know physics is again that it is not that interrelated, everything is related. If I talk about linear motion, that means x and y motion, the physics concept is same for the angular motion, angular position, velocity. So, you can connect the angular quantities with the linear quantities if you know some connecting factor. In this case, it is your radius, that is r, okay, that we need for representing. Now, I take the same schematic, but I am going to find out the velocity, because I already finished this angular motion, angular displacement. Now, let us look at the velocity. I have the coordinate, Cartesian coordinate, you have an arc, okay. The object or a car or something is initially at this point. So, this is point 1, and after sometimes the point 2, it moves on the circle to a new position. So, let us connect this with the first position, that is called what do you call it is theta 1, that is the initial angle, and after some times it reaches to a new angle, that angle which is called theta 2, or in simpler sense we can say theta I and theta final, initial and final. So, by looking at this geometry, you see the gap, the what is this angle called? This angle is delta theta, which is theta final minus theta initial. You know by default, when my object is here, that is a time initial, and object is here time final. Okay. Now, you look at your linear velocity. What is linear velocity? The linear velocity is derivative of your position over time, okay. That is linear. What is the linear velocity in here? The velocity, linear velocity or angular velocity, the angular velocity is angular displacement, that is delta theta over delta t, or you can say theta I, theta final minus theta initial over delta t. I am going to replace this linear velocity into angular velocity, that is called omega. Omega is angular displacement over time, or you can say that theta final minus theta initial over delta time. So, if I say instantaneous, omega is instantaneous, that means I just make my delta t almost 0, then I say delta theta over delta t, or you can say d theta over dt. You just take a derivative of your angle, that gives you your angular velocity. So, now I am going to again find out what are the relations. If you look at this equation, omega is equal to theta final minus theta initial over delta t. I can also write this as a linear equation, that means my theta final is theta initial plus omega delta t. This is very similar to one of the equation we use in linear motion, that means x final is equal to x initial plus v initial v delta t. This also we use in physics chapter 1 and 2 or chapter 2 and 3. This is very similar, that is why I said physics you do not need to see much difference, only it is angular scale, here it is linear scale. So, what this means? You have a angle, you have final angle, initial angle and omega t. If you do some experiment in physics, normally you plot a graph, you plot a graph on the y axis, you plot with your angular velocity. The angular velocity and your x axis, your time, you can plot a graph, a straight line, or let me say that, let me do two different graphs. One graph is, I need to find my omega. What is omega? Omega is delta theta over delta t. I can plot a graph between your angle and time, you get a straight line, that gives a slope, that slope is omega, is delta theta over delta t, or you can say theta final minus theta initial over delta t. So, that means if you plot a graph between the angle and the time, you get your angular velocity. I can also plot a graph between omega, because if you look at this equation omega and delta t, I plot a graph between omega and t, I can get some graph. For example, I can get the area of this two positions, one is omega I, omega f. You can get this integration of this or the area under the curve, which is nothing but your omega times delta t. If you plot a graph between omega and t, then that is, this area is called area under the curve, that is called your omega t. So, you do not need to find, sometime in a problem you can look at the graph and then you can also say that your omega is the omega times delta t is your area under the curve in this equation, that is called theta f and theta I. That is why I say you can find the relation between the linear position, the same here in angular position. That is about your positional coordinates. We also know that your omega is delta theta by delta t, right. What is delta theta? Delta theta is an angle, difference of angles from initial and final. So, that means we know that this is nothing but a full entire circle. If I say that theta is a 2 pi radians by t. So, you can also say 2 pi radians over t is your omega. The omega is, just take 2 pi radians, or I can also say that t, the time period is nothing but 2 pi divided by omega. You can also find how much time it takes, the period takes for a complete revolution if I know my angular velocity. So, this all how you look for your equation from your angle with respect to time. Let us go in one more step ahead to get the velocity, angular velocity, because we just got the angular position. We will just do one more step to get your angular velocity. The angular velocity and angular acceleration. Again I tell you, probably I forgot to tell you, the circular motion has two types. One is the uniform circular motion and non-uniform circular motion. The uniform circular motion where your angular speed is constant, here angular speed is not constant. That means you can go with the speed of let us say 20 meters a second or 20 miles an hour on the uniform all out, but here you can reduce the speed or increase the speed, that is a non-uniform motion. So, in the first class in previously we also discussed about if any motion is in circular, if you look at this, if any object which is in circular, there are two things involved. One is its velocity and also its acceleration. So, for any object which is on the circle, the acceleration is always towards center. The acceleration of that object we saw previously towards the center, and the velocity is towards its tangential. So, if it is counterclockwise direction, the velocity is tangential. So, the velocity is tangential for any circular motion. So, if the velocity is tangential, I can write my velocity equation is position versus r. We know that in previous case s is equal to r times theta. I can also write my linear velocity is d times r theta over dt. So, you can separate the r out and say d theta over dt. D theta over dt is your angular velocity. I can also say my velocity is equal to r omega. Again, the physics tells me the linear quantity on the left hand side, that is a linear velocity, the right hand side is the angular velocity. I can connect this linear and angular or circular by a radius. If I know my radius, I can also work on my angular and linear velocities. So, basically we are deriving this based on your circular motion, just taking your velocity and then derivative of velocity and then plug in the value which we know from previous angular quantity and get your velocity. This is a linear speed, that is angular speed. The same thing you can also write my alpha, this is called angular acceleration which is equal to r times a. This is a linear acceleration and this is a radius. So, overall I say linear position is angular position by r, linear velocity and angular velocity by r, linear acceleration, I am sorry, then this should be linear acceleration should be angular acceleration by r. Look at the consistency. Even if I go with the position, velocity and acceleration, I just get my connecting factor, that is called r. If you multiply by r, your problem is solved. That is the one which we will use. Then probably we will come to a conclusion with one more equation to get some linear kinematic angular kinematic equation. So, I say this A is a centripetal acceleration means the acceleration is, if there is a uniform motion, the acceleration is toward the center. If toward the center, what you can write is your acceleration is derivative of your velocity, right, derivative of your velocity. You know what is your velocity? Just now I said is r times omega by t. Or you can also use, so this is more like d r times omega. So, you can take out r out d omega by dt. So, that means that's your linear acceleration is r alpha. Alpha is your angular acceleration, a is your linear acceleration. Sometimes you also use a is your angular linear acceleration, which is measured by your centripetal acceleration, that is called v square over r. This is the formula we use, that is called centripetal acceleration or linear acceleration, radial acceleration. So, I am not going to derive many of the things, but I am also going to say that out of this uniform motion, you have everything toward the center, the acceleration is toward the center, then you use this formula. If the acceleration is towards a non-uniform motion, you also have tangential acceleration. You also have tangential acceleration, that is called a tangent, which is d v by dt, we can also use. So, there are two acceleration toward the center, and you also have a tangential acceleration, that is on the tangential. So, your net acceleration should be Pythagorean theorem a tan square plus a r square. So, that is our side note that we will use it. So, I am going to leave with only 3 more equations with a circular motion, that is very similar to what I wrote previously with the linear motion. If you look at this equations, I am going to write this equation in terms of circular. Omega final is omega initial plus a is turns to alpha. Look at this, alpha is my acceleration and delta t, and this one equation theta final is theta initial plus omega initial delta t plus 1/2 alpha delta t square. Let us write this equation. Omega final square is omega initial square plus 2 alpha delta theta. That is it, your problem is solved. So, nothing. So, you did a lot of problem solving for the linear motion, just all I translated with the different symbols. Instead of v I use omega, instead of s I use theta, instead of a I use alpha. So, that said, you can use all these 3 kinematics and solve the problems based on circular motion. Thank you.